Hey everyone, welcome back, and today let's solve Leetcode problem 2938 titled Separate Black and White Balls. So there are n balls in a table and each ball has a color black or white. We're given a zero-indexed binary string S of length n where 1 and 0 represent black and white balls respectively. In each step, we can choose two adjacent balls and swap them, and we have to return the minimum number of steps to group all the black balls to the right and all the white balls to the left. So in example 1, we have the input string S to be 101, and we'd output 1 because we can group all the black balls to the right in the following way. We can swap S at index 0 and S at index 1, the two adjacent balls, and make the input string S 0, 1, 1. And initially, 1s are not grouped together, requiring at least one step to group them all to the right. Right, because we know all the black balls or all the 1s should be to the right of the string, whereas all the white or the 0 balls should be to the left. So in example 2, we have the input string S to be 100, and we'd output 2 because the explanation says that we can group all of the black balls to the right in the following way. We can swap S at 0 and S at index 1 to be 0, 1, 0. And finally, we can swap S at index 1 with S at index 2 to get a resulting string of 0, 0, 1. And as we can see, all the black balls are at the right of the string, whereas all the white balls or 0 balls are at the left of the string. And it can be proven that the minimum number of steps needed is hence going to be 2, which is the value we would output. And finally, in example 3, we have the input string S to be 0, 1, 1, 1. And since this already is valid, or in other words, all of the black balls are already to the right of the string, and all the white balls are already to the left, this is already valid, and since all of them are grouped correctly to the right, we know that we don't need any extra steps to swap any adjacent balls because this already is valid. So I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a bit. Okay, so essentially, to efficiently solve this problem, we need to figure out how many swaps are required to move the 1s past these 0s to achieve our desired configuration. And to efficiently implement that solution, we're going to first use a counter variable. I'm just going to name it answer, and it's going to store the total number of swaps needed. And we'll have another variable named 1s to keep track of the number of 1s we encounter as we iterate through the string for each 0. And our algorithm essentially works by scanning the string once from left to right, and whenever we encounter a 0 or a white ball, we assume that all previously seen 1s need to pass this 0 to actually achieve the correct order at the right of the string. And that's where we actually accumulate swaps into the answer variable. And of course, this is a single pass algorithm that basically uses two counters, one for counting swaps and one for tracking the number of 1s seen so far. Okay, so with that out of the way, let's just go ahead and dive straight into the code. So first, I'm essentially going to initialize my answer variable to be 0, which is ultimately what I return after I build it up, after traversing through the input string S. And again, this variable is essentially going to store the total number of swaps required to order the 1s to the left at the end of the iteration, or traversal, if you will, of our input string S. And after I do that, I'm going to initialize a 1s variable, which is also going to be set to 0, because of course I haven't scanned through the array yet. But this is going to eventually basically keep track of the number of 1s we encounter as we go through the string at each iteration. Okay, so now once we've done that, let's just literally loop through the input string S. I'm going to say for C in S, where S is again our input string. We're basically iterating through every single character C in the string S, and as we move through the string one character at a time, we're going to then check whether the character is a string of 1 or a string of 0. And if we know, if the current element or character C, if we know it's equal to a 1, basically a black ball, right, then we know we can increment the number of 1s we've seen by 1. I probably should have named this black. It doesn't really matter. I'm just going to name it 1 because essentially if we see a black ball or a 1 ball titled 1 and for any element C in this traversal of our input string S, we can increment the number of 1s we've seen by 1. Okay? And we'll have an else conditional here. So basically that considers the case when we have a white ball or a 0 ball. And this is basically handling the case when, again, the current character is 0. And if it is 0, it means that all the previously seen ones will have to pass this 0 to achieve that correct order to the right of the input string s. And so we can increment our answer by the number of ones we've seen so far before actually hitting this 0 in this current iteration, right? And basically, again, it adds the values of the ones to the answer counter, and this operation essentially accumulates the number of swaps required to move all the previously encountered ones past the 0. And essentially, if there are n ones before this 0, each of those n ones needs one swap to move past the 0, right? Because adjacent cells can only swap, and so we'd add n swaps to the answer. And ultimately, once we're done iterating or traversing through this input string s, we can ultimately return answer. And I'm just going to unindent that so it's better to visually see what's going on. So if I were to submit this, as you can see, it's just about as efficient as you can get. So what the code really does as a whole, basically we're iterating over each character in the input string s, and if the character is a 1 or a black ball, we'll increment, of course, the number of ones counter, and if the character else is a 0 or a white ball, we'll add the number of ones seen so far up until that 0 ball to the total swaps required, which is going to be stored in answer. And finally, we're going to return the total number of swaps required to bring all the ones or black balls to the left of the zeros, to the left part of the string, or sorry, the right part of the string, right? And the core idea is essentially to accumulate swaps efficiently in one pass through the string by counting the ones encountered and using that count whenever we see a 0. Basically, we don't have to use any extra memory here. Okay, so again, the time complexity of the solution is big O of n, or linear time, where n is the length of the input string s. And that's, again, because we only iterate through the string once. It is a one-pass solution, and each operation inside that loop, basically incrementing counters and adding values, takes constant time. So this is going to be big O of n. And for the space complexity, like I was talking about before, this is going to be big O of 1, or constant time, because we're not really using any extra data structures to store any elements as we parse or process through our input string s. Okay? So honestly, if you guys are struggling to understand why this actually works, I'll try my best to better explain why, right? So essentially, we're going to use a greedy approach, and basically each 0 or white ball that comes after some number of ones or black balls implies that those ones need to be moved past it to the right part of the input string s. And instead of literally performing swaps in simulation, we can just accumulate the swap cost by counting how many ones would actually need to move past each 0. And every time we actually encounter a 0, it basically disrupts the sequence by needing all of the previous ones or black balls to jump over it to the right part of the input string s. And therefore, the total cost of swaps for that 0 is the number of ones we've seen so far, right? And why this is actually optimal is because this algorithm efficiently trades space for time by counting the ones instead of storing positions or performing multiple swaps using extra memory or data structures like an array or list. And basically how it guarantees it optimally is first we'll move ones to the right in a one-pass solution because that's equivalent to minimizing the swap operations needed to gather them at the end. And if we tried per se to perform swaps manually, like simulating each swap, it would be big O of n squared time. And so instead, by counting swaps incrementally during the pass, the solution would complete in big O of n time, right? And essentially, in the pass through the string, if the character is, again, if it's a 1, we just increment the 1